A man was pulled from his 12th-floor apartment by the wind, while furniture flew out beside him. Trucks at a nearby logistics yard were lifted off the ground and thrown 100 feet through the air. Steel beams bent like matchsticks. Thousands of homes were damaged, and 11 people did not survive the night. The typhoon responsible for all of this was still hundreds of miles offshore when it happened. That single fact changes everything you thought you understood about how tropical storms actually kill people. The date is July 2025, and the location is Hubei province, deep in the interior of central China. Hubei is not a coastal province. It sits hundreds of miles from any ocean shoreline. Drop your city in the comments. We need to know where you are watching this right now. Memphis, Oklahoma City, and St. Louis all sit above fault zones with the same dangerous depth profile. To understand what connects them to Hubei, we need to go back 10 days and go underground first. Southern Sichuan province sits 600 miles southwest of Hubei, inside mountains riddled with ancient fault lines. On June 29th, at 12 minutes past midnight, the ground cracked at a depth of 3.7 miles. That depth, 3.7 miles, is the number this entire video is going to keep returning to. A magnitude 5.5 earthquake struck Gaoxian County in Yibin City shallow, focused, and impossible to ignore. Furniture slid across floors, warning sirens fired, and the shaking reached Chengdu. 170 miles to the north, by July 1st, hundreds of aftershocks had already been recorded from that single June 29th event. Then on July 8th, that same 3.7 mile deep fault patch shook 3 more times in under 24 hours. At 6:12 in the morning, a magnitude 5.0 struck nearly the same coordinates as June 29th. Same depth. Magnitude 3.1, 3.03, 0.44, 0.0, and 3.2, the ground-fired aftershocks for nearly 4 consecutive hours. Then at 10:08 that same morning, a second magnitude 5.0 struck just 1.2 miles from the first. That 10:08 event was not a settling aftershock. It was a full rupture of that same patch. Same county, same fault zone, same 3.7 mile depth, 2 magnitude 5.0 earthquakes, barely 2 hours apart. Scientists call this a doublet, and if you watched our Venezuela episode, that word already sounds familiar. The Venezuela doublet struck at a similar shallow depth, but produced a very different kind of destruction. The morning of July 9th, a magnitude 4.8 struck at 7:44 a.m. Same location, same 3.7 mile depth. 4 major events, 10 days. Epicenters so tightly clustered they look like a single point on any map. Every one of those 4 events struck at that same 3.7 mile depth. Never deeper, never shallower. Here is the misconception that gets people killed, and you have almost certainly believed it yourself. When people see magnitude 5.0 in a news headline, most scroll past it because it sounds small. A magnitude 7 kills thousands, so magnitude 5 must be manageable, right? That logic is dangerously wrong. The magnitude scale tells you how much energy was released at the source deep inside the Earth. It tells you almost nothing about how hard the ground shakes where you are actually standing above. The variable that controls surface shaking intensity is not magnitude, it is depth below the surface, at 3.7 miles. Seismic energy barely has time to spread before it punches directly through your floor. Think of a speaker blasting at full volume right next to your ear versus across the room. Same speaker, same wattage. The experience at your ear destroys your hearing, while the room stays quiet. That is what 3.7 miles of depth does to earthquake energy. It delivers it concentrated and close. In Gaoxian, roads cracked, slopes shed rock onto mountain highways, and school walls fractured from top to bottom. A wall cracked by the first earthquake becomes the first thing to fail when the next one arrives. A slope loosened by the first tremor may not collapse until the 4th aftershock finally tips it over. The damage from a shallow cluster does not end when the shaking stops. It accumulates and waits. A doublet is more dangerous than one earthquake. The second event finds structures the first one weakened. Afghanistan and Turkey have shown what shallow magnitude 5 earthquakes do to old, unreinforced masonry buildings. Japan survives far larger earthquakes because buildings there are engineered to flex, absorb, and recover from repeated shaking. In Gaoxian, many structures were old, unreinforced masonry, never designed for the 3.7-mile punch applied repeatedly. So far, this resembles a damaging but explainable shallow earthquake sequence in a known seismic zone. But seismologists studying the cluster noticed something that separates it from typical natural sequences in this region. Every epicenter, across 10 days and 4 major events, landed within a circle barely 2 miles across. Natural sequences typically propagate along a fault as stress redistributes after the initial rupture breaks loose. This cluster did not propagate. It kept returning to the same tight 2-mile patch at 3.7 miles. That tight spatial pattern, same depth, same location, persistent return. Seismologists call this kind of sequence unusual. Southern Sichuan is not only tectonically stressed, it holds China's largest shale gas reserves underground. There are active drilling operations, old coal mines, major tunnels, and large reservoirs spread throughout this zone. China has been dramatically expanding shale gas extraction in Sichuan, specifically because of those enormous underground reserves. In Oklahoma between 2009 and 2015, wastewater injection from oil production triggered a magnitude 5.8 earthquake near Prague. In Texas, similar injection wells produced swarms of small earthquakes in communities that had never recorded one before. In the Netherlands, gas extraction at Groningen produced a magnitude 3.6 that cracked thousands of homes nearby. The mechanism behind all 3 of those cases is the same: documented scientific process-induced seismicity. Drop your city in the comments right now because this next mechanism is the most important one. Induced seismicity does not mean humans create earthquake energy from nothing the planet already built that energy. Tectonic plates have been pressing together for millions of years, loading that buried fault like a compressed spring. That fault sits locked, accumulating stress across decades, waiting for something to reduce the friction holding it closed. Human activity reduces that friction through pore pressure, and that shifts every calculation on the fault. Fluid injected under pressure into rock seeps into microscopic cracks that line the fault plane on both sides. That fluid reduces the grip between fault walls, the way oil reduces friction in a loaded hinge. The spring was fully loaded. The fluid simply removed the last lock holding the fault in place. Human activity did not create the earthquake. It simply unlocked a fault the planet had already loaded. This mechanism is confirmed in peer-reviewed studies of Oklahoma. Texas and the Groningen field in the Netherlands. The 2019 Chongqing magnitude 6.0, only 40 miles from Gaoxian, triggered exactly this debate in the scientific literature. A magnitude 6.0 is far too large to be produced directly by any blasting or drilling operation alone. A fault at 99% of its breaking strength needs only the smallest pressure nudge to finally slip. The question for Gaoxian 2025 is the same question Chongqing 2019 never fully answered for the public. Was this fault naturally at its breaking point, or did something underground provide the final pressure nudge? To know with certainty, scientists need focal mechanisms, reservoir records, injection logs, and aftershock migration patterns. Whether that data will be publicly released from southern Sichuan is a question science alone cannot compel. What the cluster already reveals is a pattern too tight, too shallow, and too repetitive to set aside, while that question sits unanswered underground. The sky above southern Sichuan was simultaneously adding another threat. Typhoon season arrived above slopes that 4 shallow earthquakes had spent 10 days fracturing from below. Water soaking into earthquake-cracked rock does not erode it gradually. It converts solid ground into flowing material. A slope that survived 4 earthquakes can still liquefy and fail during the first heavy hour of rain. But the compound threat that week was not limited to rain falling on earthquake-fractured slopes in southern Sichuan. 600 miles to the northeast, the sky above Hubei province was building something far more violent. And this is where we return to the man who was pulled from his 12th-floor apartment. What happened to him was not the earthquake's doing. It was caused entirely by the atmosphere above. 2 tornadoes tore through eastern Hubei, while the typhoon that spawned them was still hundreds of miles offshore. The storms tracked through Huanggang, Ezhou, and Xianing over several hours of continuous and escalating destruction. Nearly 5,000 homes were damaged across eastern Hubei, with dozens collapsing completely to the ground. Trucks were not flipped or rolled, they were lifted off the pavement and thrown 100 feet. Furniture from inside a 12th-floor apartment flew out through open air and fell to the street below. 11 people were killed, hundreds were injured, and the damage stretched across a broad swath of central Hubei. This was Hubei's largest tornado outbreak since 2021, spawned by a typhoon still far out at sea. Here's the dangerous assumption that every typhoon forecast map you have ever seen quietly reinforces. Every typhoon track shows a cone of danger pointed at the coastline where the storm center will arrive. That cone leads viewers to believe the worst danger is directly under the typhoon's eye, near the shore. What the cone never shows is what the typhoon's outer atmosphere is already doing hundreds of miles inland. A typhoon pumps enormous volumes of tropical moisture far ahead of its visible center into the continental interior. That moisture, combined with atmospheric instability and wind shear, can produce violent tornadoes hundreds of miles from shore. Tornadoes do not need the typhoon center overhead. They only need the ingredients the typhoon sent ahead. Picture air near the surface flowing from the south, while air a mile up flows from the west. That directional difference at altitude creates an invisible horizontal tube of spinning air between those two layers. The tube is completely invisible, no radar shows it forming, and no surface warning announces its presence. Then a thunderstorm updraft grabs that spinning tube, tilts it from horizontal to vertical, and tightens it fast. That tightened vertical column of spinning air is the rotating core of a tornado assembled in seconds. A typhoon spreads its energy across hundreds of miles, reducing its destructive force at any single location. A tornado squeezes that atmospheric energy into a path just a few hundred feet wide, inside that narrow path. Wind goes from dangerous to unsurvivable in the span of a few seconds. That concentration of force is why trucks were thrown 100 feet and why furniture left a 12th-floor window. Hubei residents know how to respond to typhoon warnings. They have practiced those responses many times before. A tornado warning there feels like fiction, something from American weather coverage, not from central Hubei province. Hubei has no tornado shelters because no planning process ever assumed they would be needed there. These tornadoes struck at night, in complete darkness, before residents could identify what the sound above them meant. 4 years had passed since Hubei's last tornado, long enough for the learned response instinct to fade. Drop your city in the comments and tell us what your community actually drills for during disaster season. Now pull back and look at everything China was managing simultaneously across those same 10 days. A dam had already broken elsewhere, sending floodwaters through lowland communities before the earthquakes or tornadoes began. 4 shallow earthquakes then fractured slopes, cracked buildings, and left the ground weakened beneath arriving typhoon rains. 2 tornadoes from a typhoon, still offshore, then tore through central China across a single overnight period. Typhoon Bavi was already strengthening in the western Pacific, stronger than the storm that had just passed. Bavi would arrive on top of ground already saturated, slopes already fractured, and drainage already pushed to capacity. Scientists have a specific name for what was building across China in those 10 days compound disaster. A compound disaster is not 3 disasters added together, it is 3 disasters multiplying each other's damage. Each event lowers the threshold the next event must reach to become catastrophic for communities sitting below. An earthquake on dry slopes is damaging the same earthquake before typhoon rain becomes a landslide engine. A typhoon on intact dry slopes causes flooding. The same typhoon on earthquake-fractured ground triggers mass failure. When Japan's 2011 earthquake struck, the tsunami it triggered arrived before rescuers had even reached earthquake survivors. Both disasters required opposite responses from the same people, and most warning systems only covered one of them. Rescue teams blocked by earthquake-triggered landslides cannot reach communities being struck by tornado damage 3 days later. Hospitals damaged by an earthquake cannot absorb the patient surge that arrives from tornadoes 3 days after. The compound disaster does not ask for attention. It simply multiplies until the threshold for catastrophe disappears. The New Madrid seismic zone runs beneath Memphis. St. Louis, and Nashville, the heart of Tornado Alley. A new major earthquake during peak tornado season would combine both threats across the same geographic zone simultaneously. The Cascadia subduction zone pairs its megaquake threat with atmospheric river storms that track inland from the Pacific. The Gulf Coast faces hurricane-spawned tornadoes, striking communities still recovering from the same storm's initial surge. Emergency infrastructure in all three zones was built for single events, not for compound sequences arriving together. The lesson from Gaoxian is not that shallow earthquakes are dangerous, that has been understood for generations. The lesson is that tight, shallow clusters demand immediate analysis, not press releases about manageable minor damage. The lesson from Hubei is not that typhoons spawn tornadoes. Meteorologists have published that for 2 decades. The lesson is that inland communities under typhoon outer bands need tornado warning systems, not only flood alerts. Compound risk demands compound preparation, and nearly every emergency system on Earth was built for only one. Drop your city one final time and tell us which threat no one ever explained to you. 4 earthquakes in 10 days, 2 tornadoes in one night. What built across China was not coincidence. The ground under Gaoxian is still loaded at that 3.7-mile depth. The sequence may not be finished. The atmosphere over eastern China is still warm, still moist, and still capable of spinning another tornado tonight. A wall cracked by the first disaster is always the first to fall when the second one arrives.